So this lesson is going to be about collecting reliable data. The learning target for this one is to be able to collect reliable data in an experiment. You guys are going to be using this for your force and motion lab. And so if we're looking at reliable data, let's say I was going to flip a quarter here. And so when I'm flipping a quarter, we both know that there's a head side and there's a tail side. And so if I flip that quarter one time, I'm going to get one of those two. And so let's say the first time that I flipped the quarter, I got heads. And then I flipped the quarter a second time and I got heads again. Right? So if I looked at my data right at this point, I would assume that the probability of me getting heads when flipping this quarter is 100% for heads, right? Because I flipped it two times and I got heads both times. But everybody knows that there's a head side and there's also a tail side. And so because I only did a couple of trials on my experiment, I would have unreliable data. And so I wouldn't know exactly what the probability is of getting heads or tails on this quarter, even though we know that I should get 50% heads and I should get 50% tails. And so in this experiment that I was doing, I collected unreliable data. And so the whole topic of this video is going to be how do we get reliable data out of our experiment. You're probably thinking of one of the answers right now is that I could just flip the quarter over and over and over. And that would absolutely be one of the ways that we could get reliable data. And so if we think about how can I increase the reliability of our data, the first way that I can do it is just to simply do more trials. Because if I flip that quarter a bunch of times, let's say I got heads, heads, and even I got another heads the third time, right? If I keep flipping that quarter, eventually I'm going to go on a streak where I get maybe a tails, then a heads, then a tails, then a tails, then another tails, and then I'll maybe get a heads, and then I'll get a tails, and then a heads, and then a tails, and a heads, and a tails, tails. And eventually, if I count these up, I've got 1, 2, 3, 4, 5, 6, 7, 8 tails, and I've got 1, 2, 3, 4, 5, 6, 7 heads. And so I'd be a lot closer to the probability that I know I should get if I flip more times. I'm going to slowly get closer and closer to 50% and 50%. And it's the same way when you're doing experimental trials. If you have this great procedure and you set it up and you do one trial of your experiment, you might get something that's just out there. And so you might assume that that's the answer to your question. But if you don't do enough trials, you're not going to really know where your data should be ending up and what you really should get. And so one of the ways to increase the reliability of our data is to just do more trials. The more times you do it, the better you're going to have. You're going to have a better idea of what you should get for your information. And then you should also be looking for the average of all of your data. Right? So that's what we're going to talk about. The next part is how do we recognize our precision? So let's say that I was going to take the temperature of something, and I was going to be measuring this temperature at a lot of different intervals, and I was doing the same experiment over and over and taking the temperature at the same point every time. And let's say my average temperature that I got, if I was going to graph this out, was at 98.6. And let's say that I took a temperature that was down at, I don't know, 96, and I had temperatures that were all the way up to 100.5. Let's say I was taking my temperature before I went to school. I mean, I got a bunch of different readings of temperature. I know that my average temperature should be right around 98.6, but I was taking temperatures and they were 96, and I was getting some temperatures that were all the way up to 105, and I was maybe doing this all in the same morning. I would know that the precision of my data was not very good because I was getting a really spread out range of temperatures, and I was probably marking temperatures all in this range. I was getting some at 98, getting some at 99, getting some at 99.5. And so if I was going to graph all of my temperatures on, this is called a bell curve here, my average is 98.6, but I'm getting temperatures that are all over the place. And so I know that I'm not very precise. Now let's say another situation, I was taking my temperature in the morning. I know that I should have right around 98.6, and my average is right around 98.6. But let's say now that my lowest temperature that I had was like 98, and the highest temperature that I had was 99. Well, if I graphed all of the temperatures that I took, I would recognize that more of my data points, the temperatures that I took, are a lot closer to my average and they're less spread out. And so I would know that this would be a very precise way of taking temperature, however I was doing it. Maybe in this one, I was using a certain type of temperature gun. In this one, I was using a mouth thermometer. And so I would know that my mouth thermometer was a lot more precise than my temperature gun that I used over here, because a lot of my data points were closer to the average. And so I know that um, my methods were a lot better in this experiment. So when you're doing this in your experiment, you can look at the precision of your data. If you're doing the same thing over and over and over and you're getting the same type of data points, then your precision is probably really good. If you're doing the same process over and over, taking your temperature or your data in the same way, but you're getting different results every time, then your precision is probably not very good. So you've got to look for ways that you can improve your precision. And so once we recognize that our precision maybe isn't so good, what we do then is we adjust when we are not precise. And so we can look for a couple of different things. In the last example, I was talking about the difference between a temperature gun and a mouth thermometer. Um, what I would do is I would notice that my temperature gun was not very precise, and I would maybe always be taking my temperature with a mouth thermometer. That'd be one way to improve the precision of my data. Maybe I would notice that my temperatures were all over the place because I was going from outside into the cold and then coming back inside. And so my forehead was feeling a little bit cold. Maybe I was in a hot shower before, and so my body temperature was a little bit higher when I came out and took my temperature. And so then I would recognize that that could be affecting my precision. And so then I'd go back to my experiment procedure and I would say, okay, I've got to control for some of these things that are affecting my precision. And so then we'd go back and we would actually change our procedure. Change our procedure because there's probably something that we are not controlling for. And so we need to make sure that we are looking back at our constants and we're controlling for all of the things that could be affecting our results. There might be something that we didn't look for the first time, we didn't recognize that would be an effect on our dependent variable, and then we've got to go back and try to adjust that procedure. And so um, these three things are really the big ways that we can increase the reliability of our data. Is if we do more trials, we're going to get rid of some of the variability in our experiments. If we recognize our precision, then we can take steps to change our procedure and make our procedure a little bit better and make it more precise and control for more factors that could possibly be affecting our data. And so hopefully through this, you're a little bit more ready to take reliable data in your experiments, and you'll be able to adjust your experiments when you see data that is not reliable.